Great. Thank you, Molly, and thank you, Jacob, and thank you, Ravi. That was really fascinating. I think some great topics emerge from this conversation. First and foremost, the need for a rigorous scientific approach to answer this question and to separate it and differentiate it from sort of the pseudoscience that has dominated the topic. It's also interesting that UAP as a phenomena, I mean, that as a phenomena, I think, although perhaps people even much longer ago than 50 or 60 years had seen things in the sky they couldn't really understand, I think it's fair to say that the sort of UFO, UAP phenomena has been something in the public conscious for about 50 or 60 years, I guess since the late 1940s. And yet one of the things that separates our time now from that period then is we do actually have the tools and technologies to do rigorous scientific inquiry on this subject. And it's a little bit like SETI, although I think in SETI, it's probably fair to say that people for thousands or even hundreds of thousands of years have looked up in the sky and wondered, are we alone? But what makes this time unique is our ability to answer that question because we have the tools and technologies to address it. So I think these are fascinating points. There's, I would certainly support and accept the funding for undertaking a program where we can apply some of the tools and techniques, things, for example, like our CAMS meteor detection camera system, which is a worldwide network of camera systems always looking up, that could be repurposed in some format to do this kind of work, at least in the optical domain. So there is lots of room, and I think lots of opportunity here. And with that, let me toss the saucer over to Molly to launch tonight's program. Molly?
Thanks, Bill. Well, good evening, everyone. I'd like to begin by providing some additional context for tonight's conversation to further what Bill said. Science fiction seemed to become reality at the end of 2017 when the New York Times reported that a government had a secret UFO program. Now, it wasn't the first government UFO investigation. There had been a few in the 50s and in the 60s. And by the time that the public had heard about this one, it had been defunct for about 5 years. But the fact that the government did have a modern UFO program blew mental gaskets. Warp speed ahead. Now we're at 2020. The Department of Defense officially releases 3 Navy videos from its once classified program. The videos appear to show objects zipping through the sky, even rotating against the wind. And according to some Navy pilots, the objects are maneuvering in a way that no known aircraft can. And it was this year, in 2020, that we learned that the government had created a new program to investigate these objects, but replaced the term UFO, unidentified flying object, with UAP, unidentified aerial phenomena. In June of this year, the UAP task force released its preliminary report on the mysterious objects seen by military pilots. Of the 144 sightings, the Pentagon was able to explain one of them. It was a balloon. It could not identify the other 143 puzzling phenomena. Were they also balloons? What about birds or domestic or foreign aircraft? It could be camera errata or visitors from outer space. Our guests tonight would like to know, but they say that UAPs have not generated the kind of scientific interest that they deserve. Ravi Kopparapu is a planetary scientist and an astrophysicist at NASA Goddard Space Flight Center. His studies include the potential habitability of Earth-like planets around other stars and atmospheric modeling using data from the Kepler Space Telescope. Welcome, Ravi.
Thank you, Molly.
Jacob Haqq Misra is a SETI astronomer and a senior research investigator at the Blue Marble Space Institute of Science. Among other things, he studies planetary habitability, atmospheric dynamics, and environmental ethics, and the big questions about the distribution and future of life in the universe. Together, they wrote an article in Scientific American, and welcome, Jacob.
Yeah, thanks for having me. Happy to be here.
Moving on with the conversation. We're very happy that you are with us. Together, Jacob and Ravi wrote an article in Scientific American in 2020 and an op-ed in the Washington Post this year, making the case that UAPs are legitimate subjects for scientific study. So let's find out why they think so. Jacob, I'm going to start with you. The behavior of these objects is puzzling, to say the least. Do any of the objects in these videos move in a way that make you say, holy cow, how could anything on Earth move like that? Just so we can have an image in our minds as we proceed with this conversation. Could you select one of the objects in one of the videos and describe why its movement is so hard to explain?
Sure. Yeah, this is why these videos are so interesting. And so in 2004, it was the USS Nimitz and encountered several objects, and that's some of what's captured in these videos. And so what's puzzling about these objects is their rapid movement. You see things like an object descending from 28,000 feet to sea level in less than a second. And so, if you try to estimate the acceleration on these kind of objects, you get anywhere from hundreds to thousands of times the force of gravity, which would, not even our most trained pilots wouldn't be able to survive this. And the amount of energy required to have that kind of acceleration is just beyond the kind of technology that we have today. So just based on that alone, this is something if it's not violating the laws of physics, it's using physics in ways we don't know how to do yet.
Mm-hmm. And these are very short videos, though, so we only get snippets of the behavior of these objects.
There's short videos, there's some radar data, there's some eyewitness accounts. We'll get into the conversation more, but there's not enough data to say what they are yet. But there's enough snippets of data to make me say, hey, this is really interesting. And whatever it is, this is something about physics that we don't really understand yet.
Okay, so that's making the case for why maybe we should study them. But Ravi, how do we know that these are physical objects and not just quirks of the instruments? I mean, these are really sophisticated instruments, and they're highly they're designed for precise calculations on these aircraft. How do we know that what we're seeing are not just quirks of the instruments?
Right. I'm going to address this with 2 points. If we are talking about the recent Navy incidents, it is certainly possible that some of these are instrumental artifacts. The DNI report does mention that some of them could be the result of sensor errors and probably require additional rigorous analysis. But what we have seen in the public,
okay, let's take that from the top. So you said, so my question was, how do we know that these aren't just errata in the instrumentation?
Right. So what I was saying is that if we really are talking about the recent Navy incidents, and it's certainly possible that these are instrumental artifacts, the DNI report, of course, does mention that there could be sensor errors and require some more study and analysis. Like you said, what we have seen is just snippets of data. However, these UAP are not a single type of object to explain away that they are instrumental artifacts. Their appearances and behaviors indicate multiple type of UAPs, so may require different explanation. There is even more fundamental issue here. We are now caught up with this relatively recent news, UAP news. This phenomenon is not a new thing. It has been going on for decades, and if Professor James McDonnell in his Science in Default document has written about 4 cases. Are all the events in the past and around the world that's happening could be explained away by instrumental issues. I mean, while the recent events got understandably highlighted the UAP discussion, we should remember the history. History is important to give us a context so that we can understand our own biases.
Okay, we'll pause it before we get to too much of the history, but now you've made the case that while some of them may be glitches in the instruments, these seem to be physical objects. They seem to be, the events seem to be happening around the world. The two of you would like to study them more rigorously, but the objects have already been studied by the Pentagon. So for both of you, what more do you hope to learn, and what can scientists do, and the team of scientists that you would like to pull together, what can they do that hasn't already been done?
Well, I would like to know what they are. And this is the point we made in our Washington Post article, is that a lot of times these conversations focus on, they focus on what are they, and we want to answer that question now. And I want to answer that question, but the real question we have to ask first is, how can we understand what they are? And there's a large percentage of these objects that seem to be objects in the sense that they appear on radar. There might be infrared camera observations. There might be eyewitness sightings. So multiple wavelengths, multiple pieces of data indicating that it's an object. And a larger fraction of these are unexplained than we would usually accept in any other field of science. And so when there's that much to be explained, do they all fall in the categories of birds or airplanes or weather balloons? If that's the case, we should understand why we have such a hard time identifying those things.
Well, let's be clear, though, because I think there's no dispute that these objects are truly puzzling. But what is it that scientists could do that the Pentagon didn't already do? Because they went through all of this. They could answer some of them. They couldn't answer. They couldn't identify what some of the other objects were. What is it that your team, and you've been calling for an interdisciplinary team of scientists to study them, what could they do that the government wasn't able to do?
Well, we don't have access to the government data. There's been very little data that's been declassified. There's various reasons for that. I would love for data to be declassified, but you'd probably have to reveal information about your instrument in order to make sense of the data. That instrument is probably very secret, and maybe it's good that we're not declassifying that, but for better or for worse, we don't have access. I don't know what the Pentagon has done. They may have some secret report that will never be released. I'm not an insider at all. All I know is that there's been enough information coming from the US government and then elsewhere beyond the US government to say that multiple governments and agencies and non-government actors all take this seriously and find observations. But what you would need, if you want to get past this classified wall of data, is to take your own independent data. You need to take data at multiple wavelengths, at infrared, take radio data, take optical, record with cameras. You can use some of the global sensor networks that are already in place by agencies like NASA and others where the data is publicly disclosed, and then supplement that with anything that you can build if there's funding available to really take continuous measurements, not just sample the sky once per day, but you need to have continuous measurements of as much of the sky as you can, which fundamentally is similar to the problem SETI does. It's just you're looking at a different distance. Instead of trying to look far away for radio signals at the whole sky all the time, you want to look a little bit closer in, but still the whole sky all the time, ideally, if you really want to know what's there.
And we'll come back to some of the methods that you may be using, but you've given us a nice outline of how you might do that. But the key here is that you want to do independent investigation. So this isn't about trying to get access to the UAP task force report or look at it more carefully, or try to get the Pentagon to give you information that they're not giving up, or even to go back to those initial videos. It sounds like you're talking about something where you gather the data on your own as an independent body of scientists. Is that right? And
I would love to see what the Pentagon has, but I don't think we're going to get it, and I don't think it's worth barking up that tree. And Ravi can talk more about the historical cases. We should learn from what has been done, because there is a lot of just in terms of the methods and the questions that you ask, but we don't have data from those old cases either. We don't have enough data to be able to really do any kind of assessment. So we need to collect new data.
Well, Ravi's been talking about the history. Can you give us just an overview of how, if this is what you mean, how the past historical investigations, and it could be anything from the Condon report to the government projects of Sign, Grudge, and Blue Book. I believe those were the names. The names shifted as time went on. Is that what you mean, Ravi? Is like, look at how they did it in the past and get some guidance from those earlier investigations?
Right. So there were some reports written in the last 50 years ago. And I would say some of the, whatever the report's conclusions are, there was a scientific investigation, some sort of a scientific investigation
Are you
was
talking
done.
about the Condon report
Ye-
in the 60s, late 60s?
Right. Not just the Condon report. I'm also talking about the Condon report was the result and was the one that came out in the late 60s that, essentially said maybe it's not, UFOs are not scientifically what important to investigate or something like that. But I would say that the lesson that we want to learn is there was actually something done about it. And it was okay to talk about a scientific investigation, to do research on these UAPs. James McDonald disagreed with some of the results from the Condon report and tried to assess some of the cases that were discussed in the Condon report itself. And so you see, that kind of debate is needed. We can't just say that, let's not study them because whatever, they are instrumental artifacts. But this is the way science is done. Let's have a discussion on the science, how it is done, and then we will go ahead and see how, like Jacob is saying, collect the data and to see how and what we learn about them.
Now, you've brought up something that I think is what's underpinning your argument for why it's important to study these. And that has to do with the reason why we haven't studied these. So you said that there was a period of time when we were studying them, and that wasn't a problem. But now there's a taboo around it. And at least that's my understanding from what you've written. I wonder if the two of you could address why studying this sort of phenomena of UFOs or UAPs has been considered taboo among scientists. And when did that happen? Because as you said, maybe 50 years ago, it wasn't taboo.
I'll let Jacob answer first, and then I'll have a follow-up with that.
Okay, well, I think the obvious answer is it's guilt by association. When you say UFO, people think of saucers and little green men and alien abductions and everything else. And, very quickly, I'll tell you, I went, a couple years ago before the pandemic to the Library of Congress. I went through Carl Sagan's files there, and he had several files on UFOs. Mostly it was letters, about half of it was letters people had written him. But then he collected, various pieces of, writing that interested him. And there were, crop circles were in there because at the time we didn't even know the answer to were crop circles a hoax or not, or what caused that. And so just being open-minded enough to look at all that, I thought it was interesting that Sagan was just collecting all that data. And so the fact that all of those topics are under, even in Carl Sagan's file folders, are all under UFO, that makes it really difficult to then focus on a very narrow set of anomalous objects in the sky that may sometimes be confused for airplanes or birds or weather balloons, but has, to decouple it from the other sort of paranormal other topics, and maybe some topics that are even worthy of study, but have nothing to do with objects that are in the sky. And I think that's really the problem is if you say UFOs, it assumes all of this pseudoscientific paranormal content, and a lot of scientists just would rather distance themselves from that rather than sort of implicate themselves in pseudoscience.
And we should be clear that the crop circle mystery was cleared up and the guys came forward. And my colleague Seth Shostak always liked to say, why was it that those crop circles were always made like after 5 p.m. on Friday and on the weekend? But anyway, crop circles is not a mystery. What might be flying around our skies is. And in fact, the taboo around it is one of the reasons why the government changed the program from UFO study to UAP, because what they said was that if you could reduce the stigma around it, you might get pilots coming forward more often and just admitting to what they saw. So the stigma also extends to the community of pilots as well. On the idea that this might be something else other than a craft, and I think that that's really important going into your investigations. Both of you have said going into this investigation doesn't mean that you're looking for evidence of alien craft, and you want to decouple that. And Ravi, you compare the study of UAPs to the initial study by scientists of astronomical phenomena like gamma ray bursts or supernovae or gravitational waves. They seem very different from what we're seeing in our skies, but what's the connection there?
Oh, I was talking about the transient phenomena and the transient nature of these astronomical phenomena and how scientists study them. And so there is a precedent about how we do that, how with what kind of instruments and how we collaborate, share data, collect new data, publish, the scientific process. So that is the context that I was talking about. How do we study transient phenomena? The UAPs are transient. Some of them, many of them, are transient phenomena themselves. And so,
just to be clear, when you say you called for this, this is something you called for in some of your writing, I think in the Washington Post or the Scientific American article. That's what you mean.
That's right.
And transient, they're just very brief. And also some of these UAPs, they don't repeat. So you get one shot, right? Is that one of the problem?
Right, but it's a class of phenomena that we need to observe, right? So just like a gamma ray burst or a supernova. So we know that it is a gamma ray burst, or we know the nature of the astrophysical nature of these transient phenomena because we studied them. If I just see something, a bright shiny object in the sky, if an astronomer, and then I try not to share the data, or I just try not to study it, but then make it a taboo to study that phenomena, we will never progress. We will never understand it. Maybe when we study these UAPs, all UAPs may turn out to be mundane. Totally fine, totally cool. But then let's do a scientific process to understand them. And so that we will know what they are rather than a speculation.
Will you be disappointed if they're all balloons?
I have no reason. No, not at all. we have.
What did you say?
Our approach is agnostic, right? So we should be open to everything. If it's a balloon, that's great. Fine. It's a strange kind of balloon, then I'll know something.
Okay, well, the two of you are calling for an interdisciplinary team, which means scientists from all different kinds of disciplines. What sort of disciplines do you want to include in this team?
So in this case, from what we have learned, at least the ones that we have seen, these appear to be mostly in the Earth's atmospheric phenomena. So we should have, aerospace and aviation related people, experts in this. We need probably meteorologists. Jacob is, of course, a meteorologist and has a degree in meteorology. We should have physical scientists to understand what is going on. So at least these disciplines would be good to start with. I wouldn't say this is the comprehensive list, but these would be these 3 or 4 expertise would be really useful to start working on.
And this would be around the world, or that doesn't matter?
If an expert is an expert. So if we want to.
Okay. Well, could the two of you give us a real sense of what these studies would look like? I mean, Jacob gave an overview, but are we talking about scientists for a discrete period of time, setting up observation stands, or just pouring through data, or how would you collect the information that you want to collect? For one, like you said, these phenomena are transient. So do you set up telescopes or infrared video or radar data collecting sites and just wait? Or what would this look like?
So something like that, I would say, and probably some fast tracking cameras, because when we were talking about transient phenomena as well, and different spectral wavelengths, different wavelengths. Some of them could be optical infrared, maybe in the UV, maybe in the long far infrared, and even in the radio would be good. Will
you tell us why? Will you just tell us why it's so important to get all those different wavelengths?
Right. So radar, I would probably maybe because we can potentially obtain some sort of a speed or the range for these some of these objects. Infrared, because to see if they are emitting any thermal radiation, heat. Optical, just because to see how they operate in the visual band, and what do we see in the visual band.
Right, that's in the visual wavelength.
Yeah, that's what I mean.
What we're using right now.
Correct.
Yeah. And then you said something fast tracking. Did you say fast tracking radar or fast tracking
Cameras, I would say.
cameras? Why are those important?
Well, because these are transient, right? Phenomena. I don't know. This goes into a little bit more detail. I'll probably have to talk to experts on this one. If we have this is the problem, right? To know how fast we want to track them, we need to start with something, and then see if we can track any of these objects. Maybe initially we may be successful with some of the some objects to see how fast we will be they are going. Maybe then we can fine tune, refine our instruments. So this is how the process has to start. We have to start at some place.
Right. And Jacob, would these be ground-based observations, or will you try to get, as Ravi said, this is in the atmosphere, upper atmosphere? How will you get up there to watch?
Right. I mean, ultimately it's dependent on, is there funding available and how much funding is available. So if you had unlimited funding, you would have a network of space-based monitors. But, realistically, funding is limited. You'd have a ground-based network with global coverage to the extent that you could. One thing in the UAP task force report that, I'm not putting like tons of faith in the government, but the government does say in the report that they're calling for more intergovernmental cooperation to share data to try to identify these. And so that kind of model is, we can pull from data that NASA satellites are taking, for example, and other public government and other non-US government sources of data that are available for anyone, and then collect our own data. And you're going to have some hire some postdocs or something to sit and pour through this data. And I mean,
it's always the postdocs. It's always
there might be something that could be learned right now without collecting too much more additional data, but really just carefully comparing data from multiple data sets that don't always get compared. So that might be another place to start while we're trying to collect new data.
And have you had scientists contact you and say, we want to be a part of this if we can just get the funding and the organization together? They answered your call, in other words?
I mean, I don't know that there's funding available that we've seen. There's certainly scientists who have contacted us and say they're interested in talking about this. They agree that there shouldn't be a taboo, and I think that's probably been the most encouraging result of the U.S. government taking a formal position on this. Is that's helped to break down the taboo. It's not. There's still not mainstream scientific investigation of UAP. But, we're here talking to you. I'm not worried about my career, what's going to happen tomorrow. 10 years ago, that might not have been the case. It might have been riskier for me and Ravi to be having this conversation, which I don't like that. I think you should be able to talk about anything. As scientists, it should all be open if you're being honest with how you're asking the questions. So
it's not just taboo, it's taboo with consequences. So it's one thing.
It has been for some people.
I see. These objects, this idea of providing some kind of global network in your wish list, and you should present your wish list. It's always good to hear if there were no restrictions, what anyone would want. But if you had to narrow it a little bit, these objects are often seen by pilots, and it's over water, it's over often military compounds and around airports. Does that guide you? In other words, is there anything about where the phenomena are spotted that would inform how you study them?
I would go ahead, Jacob. You want to?
I'll just, briefly. I mean, I think commercial pilots would be one place to go because it's not connected to the military at all. And so there's been some sightings by commercial pilots. Maybe look at those a little bit. I don't know if there's patterns that would be even reasonable to predict. I have a hard time believing, but in any case, you could do something with, commercial pilots or even just private planes flying at high altitudes is, one place you could start.
I agree. I think maybe some of the places where there have been reported UAP events maybe would be a good start and see or talk to the people who have been involved in this before and see if we can have these instruments near those places. Would be a good place to start.
Did I characterize that right? That often it is over military compounds and over water?
I would say that's an observational bias, because that's where the reports are coming from. That doesn't mean that's the only place they are going to be there.
Okay, excellent point. Just to follow up on the pilots, and this is just a curiosity of mine, and I don't know if you've talked to any pilots, but most of these reports, when they are reports from Navy pilots or pilots, they're obviously reporting what they don't understand. But has anyone gotten accounts directly from pilots who do know what they're seeing, but maybe initially they didn't know what they were seeing? They didn't know what they were seeing at first. Then they figured it out. But of course, they would never report that. That would never become an incident, be an incident report. Has anyone, just curious, has anyone talked to pilots who have said, oh yeah, I saw something like that, and then I figured it out, it was a balloon or whatever it would be?
So
did I stump you?
No.
Oh, okay.
Did anyone, as in either one of us, or
no? But I'm not asking if one of you have, but I just wonder if that's also a way of going, is not just what's been reported, but maybe what hasn't been reported or what has been resolved. It's just something I was thinking about when we were talking about what pilots have seen.
Well, I mean, that's part of what you would do in investigation, especially if you were trying to incorporate eyewitness accounts. You can't base, it's very dubious to base an entire investigation on eyewitness accounts. But if you have radar and you have video and then you have eyewitness accounts, then you want to talk to those people. And there's methods for how you do oral interviews and understanding how the story changes based on the first sighting and the retellings of that story. So yeah, presumably that would come out if there was a report that a pilot saw a UAP and it got recorded, and then you're following up on this investigation later. You would interview the pilot, and if they now know what it is, then a good investigation would have interviewed the pilot to make sure they get that story.
So this sounds like what you're asking for is something that is quite layered. So you're using the instruments to collect the data, but then also talk to the eyewitnesses and then try to bring it all together to get a comprehensive understanding.
Yeah, I mean, ideally, you would have so many sensors that you wouldn't even need to talk to anybody, just the way we do exoplanets, to remove any ambiguity. But at least to start with, if these are transient events and we don't even know exactly where to search and we have limited resources, you probably have to at least, take that into account. You don't have to believe everything everybody says, but there's, Ravi, you're talking about who needs to be involved in this. You need social scientists involved, people who understand how to conduct interviews and how to take oral histories and the methodology involved in that.
So I'd like to say something over here. So yes, social scientists are involved in that, probably because I guess, Jacob, you mean because of the eyewitness accounts. Is that
how to do the interviews? Yes.
Yes.
That's an art, just like we know how to run, experiments and telescopes. Just how do you do an interview is a skill that I'm not trained in.
Right. So, but for an actual scientific investigation, data, and instrumental data, let me be more clear on that. And instrumental data is the one that we need to make some progress on understanding these UAPs. So while eyewitness accounts are really good, because that will give us an idea about what people may have seen, having an instrumental data is the one that actually would help us in understanding and making some sort of a leaps in understanding these objects. So well, the reason why I am a little bit hesitant on that is because there is a social science part of this, and there is an actual physical science aspect for this one. So my interest is in the physical science part of it. I know eyewitness accounts are, where people would want to go and see if they, verify or ask questions about. But physical data is what really matters if we want to make anything out of this.
Mm-hmm. Let's step back for a little bit and look at this scientific process in general, because this is not the first scientific subject that had that was once that is taboo, or that was once taboo to study. And I wonder if you both, one of you or you both, could give an example of a scientific phenomena that was once taboo, but we studied it anyway, and it yielded some important results. Are there examples of that have slipped our minds?
Yeah, absolutely. So I'll give one is endosymbiosis. So this is the idea that our cells actually have a little mini cell inside it, the mitochondria, the powerhouse of the cell, and in a plant, it's chloroplasts. And the hypothesis was that these were separate organisms that got swallowed up by the cell. And Lynn Margulis was one of the champions of this idea. And it was, basically ridiculed that doesn't make any sense, that a cell would swallow up another organism and become a dual organism cell. And we know this is correct now, because we can take the DNA from mitochondria and chloroplasts and show that it's unique, separate DNA from the cell. And so, it completely revolutionized the way we think about evolution and biology. And yeah, at one point, you could probably risk your job by saying that was a research interest.
That's incredible, because that's such a fundamental understanding of biology now, that cells have mitochondria and that they were originally probably free living cells that were swallowed up by the mother cell or father cell. Ravi, what were you going to say? Excuse me.
No, I was saying plate tectonics is another taboo subject.
That's very recent.
That's very recent.
Mm-hmm.
Right. So, yeah, that was another scientific topic that was a taboo, but taboo in the sense stigmatized. But it was, now we know the Earth operates, the geophysical mechanisms of Earth is based on the cycling of the mantle and the inner mantle, and then the crust, the surface of the Earth, operates with the plate tectonic mechanism. So if we can study those things, because people were interested in that. So we should do a similar scientific study on these UFPs as well. Mm-hmm. This is how we inform the general public, the scientific process. This is an excellent way of teaching scientific process to non-scientists. So take this opportunity.
So you're saying that would be the added benefit. That's the added benefit.
Correct.
Well, I like the plate tectonics example that Ravi brings up, because it was Alfred Wegener who proposed this idea of continental drift. So he didn't actually know about plate tectonics, but he noticed the continents had similar shapes, and there was fossil distributions that lined up if you move the continents together. And part of the reason that the hypothesis of continental drift, just continents moving, was rejected at his time, was because he lacked an explanatory mechanism. And you had to wait until we discovered seafloor spreading and plate tectonics arrived, and then kind of he was vindicated retrospectively, Wegener's hypothesis. And so there's sort of some parallels here with UAP. I don't like to put forth a hypothesis in terms of what they are. The most I'll say is they seem to be objects and worth studying. But you don't have to have a full theoretical explanation for what you're studying in order to study it. There's lots of examples of that in science, and plate tectonics is a great one. So we could have kept studying continental drift, and maybe we would have arrived at plate tectonics sooner if we've just been a little more open-minded.
Now, you said you don't like to engage in speculation, but is it all right if I do?
It's your show, sure.
I don't know if it's my show, but okay. Okay, so while I was preparing for this, I read something in the New York Times that was reported in October, and it was a pretty startling, at least I thought so. The Pentagon reported that China had caught them by surprise by testing a hypersonic missile. And the Pentagon described it as China's Sputnik moment. So it wasn't a small thing, it was a big thing. The way this missile moves sounds a lot like some of these UAPs. It's described as a hypersonic missile that can change course suddenly, it can zigzag, and it can move in ways that would render all US missile defenses obsolete. Now, no one in this article or the other articles that I read about this, and this was just a few weeks ago, has made the connection to the UAP report. And I'm wondering, is it possible that the answer to what these are is right in front of us?
I would like to point out first that this is, again, based on the recent reports. 50 years ago, if anyone else on this planet had that kind of capability, then I would say probably 60 years ago, 50, 60 years ago. So while it is certainly possible that some of these objects may be from other nations, this explanation cannot be, we cannot have a blanket explanation for all the cases all over the world every time in the past, present, the recent past, any time. So yes, it is possible that it could be from, some of these could be from some other countries, but there are just too many cases to have this explanation valid for all of them.
Okay, fair enough. I want to remind people who are listening, audience members, that you can write questions to us, and we're going to start taking questions very soon. I have another one, though, before we move into audience questions. Ravi and Jacob, how do you know when the study is over? At some point, the Condon report, for example, in the 60s ended. At what point do you say, well, we were able to identify these objects, or we couldn't identify these objects? We can't identify all of the objects. And does that mean that we just need to accept that some things can't be explained? But the question is, when is the study over?
Yeah, that's a great question. And, we have the same problem in our other research that we both do, which is we want to search exoplanets for signs of life, biosignatures or technosignatures, stuff the SETI Institute is interested in too. How do we know when we've searched enough planets to say there's no life? Like, let's say we don't find anything right away. How do we search 1,000 planets or 10,000? And so, there's no end to when you've searched enough to conclude a negative answer. But you can have some sort of statistical sense, like, well, if we've explained 90% of the unexplained cases and there's 10% left or 1% left, there has to be a little bit of a sense of we've done a statistically complete job and we've found nothing. At this point, we're going to step back and reevaluate. But, we're not there yet with exoplanets in biosignatures. We're just scratching the surface of that. The NASA, the decadal survey report favorably recommended an exoplanet finding mission. That won't even get us there. That'll find 20 some planets, and I'll be an old man at that point. So, when have we searched enough for life in the universe on exoplanets? Probably when people's great grandchildren in this call are old, assuming the funding continues to mount to support those kind of telescopes. So I think we'd be a long way off for UAP until we have a real data collection effort underway.
Okay. So can I quickly add something on that?
Yes, and then we'll go to some, so you can imagine that the audience has lots of questions. Yeah, go ahead, Ravi.
Yeah, so one of the things that when we found the first exoplanet, because we work in exoplanets, I'm giving the examples of exoplanet. When we discovered the first exoplanet, we didn't stop there. We said, okay, well, we found an exoplanet, let's go ahead. And we understood. No, when we found hundreds and thousands of them now we know that the most common exoplanet is probably a mini Neptune-sized planet, and in our galaxy. And so that's a statistical study. And now we are trying to find out biosignatures or technosignatures in them. When we find one of them, we don't close our telescopes and go back and do something else. We want to find the distribution of life in the universe. So unfortunately, I'm not trying to connect this search for life with UAPs. In my view, they are totally different unless something strong comes into picture that, there is some connection. So this is why we need to do this there is no end to this.
Well, there is an end to this discussion here. This is a SETI talk, of course, and we're discussing whether or not UAPs are a appropriate scientific study. And we do have some questions. So the first question from the audience is, and I'm reading the questions that have been posted here. What is the protocol for public release if UAPs are confirmed as extraterrestrial technology? So if you do decide that it's extraterrestrial, how are you going to break it to us?
Well, so there's if it's the U.S. government, that has nothing to do with us, and there's secrecy and classification and all that. But if this were, in the hands of private citizens and just scientists doing work, I mean, this is analogous to, again, not that UAPs are necessarily aliens, but finding something like the SETI Institute wants to find extraterrestrial life. How do you announce that? There's been some discussions of, do you have protocols? How do you'd certainly want to check your work before you announce something big like that. You'd maybe call up some friends and make sure they can corroborate your observations and check your calculations. And so you'd at least nominally want to have that. And so, there are some discussions and published protocols that aren't legally binding in any sense, but they make some recommendations as to how do you, responsibly disseminate the information, where you certainly don't want to sit on this and keep it from people who really want to know, but also make sure that you're not putting information out there that then you have to retract later.
Okay, great. So there is a protocol there, and I suppose if you do find something as interesting as an alien craft, you will have a little bit of time to make sure that you let us all know in the appropriate way. We have some more questions here, and I'll just maybe ask that we'll keep the answers sort of brief so we can get through these because people are so interested. The next question is, how much money is needed to fund a surveillance network? Maybe the ideal network that Jacob said he would like to have. What are we looking at here? Ballpark.
I mean, it would probably be, on the order of hundreds of millions to, billion or so if you really wanted to do it seriously. I mean, NASA flagship missions are billions of dollars. The breakthrough initiatives are $100 million efforts to scan the sky. So, I mean, I think if you really want to seriously collect data in a global scale, it's going to have a big price tag like that.
Okay, big price tag. We'll just go with that. It's a big price tag. That's fair enough. I think we can all probably imagine. This other one is a little bit more specific. How can we train our observational systems and sensors to recognize if there are unknown craft entering or exiting the atmosphere at high velocity? Or exhibiting the observables described by the AATIP, which is the government report, I think. How do you do that? How do you set up a network that would be able to observe if objects were entering or leaving our atmosphere?
So there's a lot of things that are influxing and outfluxing, influxing into the Earth's atmosphere. So noise is a big factor here. So we need noises, right? So we need to have a good algorithms to distill out the noise and have identify the interesting ones. Even if you find something, it may not be the one that you were looking for. Maybe it's something that you overlooked. And so to do that, we need to have a good analysis methods, algorithms that can be trained. Those are the machine learning and artificial intelligence algorithms are probably the ones that we need to focus on developing.
So you'd be collecting the raw data, observing the skies, and then using these algorithms to filter out. And this actually folds into the next question is, and I think you've answered this, but maybe if you don't mind summarizing again, is how you would sort out the thousands of astronomical transients that happen every night. This audience member is saying that he or she goes camping, and when they're in a very dark area, you see meteors, you see lots of things happening up there. So how do you filter out some of those, if you say natural, I use that word in quotes, but natural phenomena?
Well, we know some nature of some of these astronomical transient phenomena, right? So if we have the data, maybe we can rule out some portion of the data collected just by comparison with the known astronomical phenomena characteristics. And even if some of them are left over beyond that, they may still turn out to be the known phenomena, astronomical phenomena, just because they may be, having different characteristics than what we have not observed before. Mm-hmm. So, like I said, there won't be a aha moment and saying, oh, here is something that is totally different. You will find several of them totally different. but you will have to carefully knowledge. This is where our what do you call, understanding of the noise phenomena comes into picture. We cannot say that we found something. We can only say that these look interesting, and that's where we have to stop. We cannot go beyond.
Do the objects look like any kind of astronomical phenomena that either one of you are familiar with? Anything?
Potential misidentification can always happen. So yes, some of them could possibly look like some astronomical phenomena. But then again, given the kind of data, if you have a spectral data, the wavelength data, if you have some kind of a movement data, maybe then we can sort out and then filter out. Otherwise, they may look similar.
But I mean, when you looked at those videos, did you say, "Oh God, that looks a little bit like a meteor. That looks like"?
Based on the snippets of data, the pilots have seen something, and they say they see something. So I think that is not a meteor.
I want to get to the other questions here, but in your article, you quote Carl Sagan, and you say that you quote him, and he says, "Scientists are particularly bound to have open minds. That is the lifeblood of science." And that goes to the point that Ravi just made right now. In what way would this UAP study be an exemplar of the way that science is supposed to be done? And what is the role of humility in this? And that is a word that you used in a conversation I had with you, Jacob. So what would this mean in terms of being a demonstration of the best of a scientific endeavor?
Sure. Yeah. As scientists, we don't become scientists because we know everything. And I think some scientists forget that we don't know everything and therefore we're scientists. We're actually scientists because we don't know so much about the universe and because we want to know. That's why we're scientists. And so if there's something that we don't know what it is, it's anomalous. It's an object in the sky. We don't know what it is. That should be something that gets scientists excited. Maybe not every single scientist, but enough of them because it's something we don't understand. And so I think there's sort of a humility that needs to be at the core of what drives us as scientists, that we don't know, and we're actually always trying to prove our models and our hypotheses wrong to learn more. And we don't want to we're not trying to arrive at the top of the mountain and say, all right, I figured it all out now. I think this hubris kind of can infect science a little bit too much, and we definitely need more humility in terms of just realizing that we really don't know a lot about the universe still.
I'd like to offer a counterpoint on that. Scientists are, understandably skeptical and conservative because it needs a rigorous analysis and rigorous testing. That is how everything we know now, we have now, is because of the scientific methodology we have, followed through. But it has its drawbacks. Process takes time, so some things may get delayed. But in the end, the thing that stands of all these tests will remain as the solid explanation for something. So the process is difficult, the process is skeptical, the process is conservative, but it works.
The processes also include publishing. And that brings me to the next question that an audience member has, which is, will you publish the study? And will you publish it in something called a UAP journal? Will there be a journal like that? And will these be peer reviewed?
Yes, I think that is publishing is one thing that has to happen, and because that's where we can share the data. People can, our colleagues can criticize it. That's good for science. And then, may poke holes in our analysis. That's again good, because then we will refine it and see what we have our own, not we as not in just Jacob and I, but in general, the people who publish. So it need to be published because we can share the data, we can share the results, and people can test it.
Okay, and there's another one. Thank you for that. I just there's a lot of questions here, and they're scrolling by pretty fast. This next question is about funding again, and where this is a little bit different from how much, but the question is, where would the funding come from?
Presumably from private philanthropists. If the U.S. government agencies are interested in funding this, I'm not seeing any indication of that just yet. So presumably this would be private funding.
Okay, private funding. And are you willing to, okay, let me ask this then. If of all the possible conclusions of the nature of these objects, what result would be the most scientifically important and personally exciting to you? And this may be our last. There's one other question I'm going to ask you about how the public can get involved, but this may require some speculation. And I know Ravi was saying you want to be very careful about that. But if you could just now share with us what would be the most scientifically important and what would actually personally be very, very exciting. And I know balloons is one of them, because I know you got very excited by the idea that there's 400 different kinds of balloons. But what else might it be?
I would defer this to Jacob.
No. I think you're required to answer this.
I have to be careful here because I try to avoid this kind of speculations, and anything that follows a scientific method, and then whatever comes out of it I would rest, and I would be more comfortable trusting that results, and I would be more excited about that, because then I know I'm excited for the right reasons.
Okay, so it sounds like what would excite you is to have an answer and to feel like you had gone through the method, the appropriate, the method of science, and it was a rigorous study, and you came up with some conclusion at the end.
Correct.
Okay, and you wouldn't be just a little excited if it were aliens? A little bit?
Little bit is an understatement.
Okay. So he's revealing that. Jacob, how about you? Scientifically important and maybe just personally would be very exciting.
Sure. Well, one of the things that drew me to this topic is the fact that it's a taboo. It's because as a scientist, that really irks just my core sensibilities of you can't tell me that I'm not allowed to study something if I think it's interesting. And so in that sense, having this conversation and writing, articles is encouraging for me. And I would be, in that sense, happy if, 10 or 20 years from now, you could be a professor and UAP is one of your research portfolio items and nobody blinks twice at it and there's funding available for it. Even if it's an ongoing inquiry at that point, I would be really excited that, we were a small part of bringing a field into the mainstream from the fringes and acknowledging that there's something interesting. So I would be really happy about that. But I will say, if there's really, if what we see, not just from the Navy videos, but, observations that have been reported over time, if there's really unknown physics that we don't understand, I would be really excited to learn something really new about physics, something that challenges what we learned in our college physics classes and forces us to reconceptualize, our technology. I don't even care what the source is. I'm an astrobiologist. Of course, I'd be excited about finding aliens, just, even on an exoplanet. But in terms of what UAP are, even if it's totally decoupled from anything extraterrestrial, but it teaches us new physics, that would be really cool.
So if it's on the in the ballpark of something like dark energy or dark matter or something like that.
Sure, that would be cool.
The finding of dark energy, that's actually quite decent.
Anything, it's something we don't understand. And then if it's mundane, if it's something that they're all balloons, but for some reason they all got misclassified, well, that seems important. That might even be like a safety risk or national defense. If we're misidentifying that many mundane objects, there was still something we didn't know.
Yeah. We do have time for a few more questions, but that is one of them. Do you think that these objects pose a risk to people, to aircraft? Yeah,
it is a safety issue.
There is a safety issue.
Because we hear from pilots who have reported, we don't somehow, if this is a stigmatized topic and a taboo, we don't hear from, several others. So this is a classic example of absence of evidence is not an evidence of absence.
Mm-hmm. Jacob, you said that you would not be, I'm paraphrasing, so I don't know if I have this exactly right, but you would not be disappointed if it weren't aliens, if it were some other physical phenomena. That would be terrific. But let's say that that they are alien craft. Would that make you feel as though your work in SETI, the search for extraterrestrial intelligence, had been for nothing? That's a question from one of our listeners, that listening for these signals in the end was all for naught because they were here visiting us all the,
that is a great question. And so, I'm my interest in SETI is not just in listening for radio signals for exoplanets. I mean, I'll make this quick, but we should look for atmospheric pollution and other things, not just radio signals. But there's also other things we can look for in SETI. We've sent the Voyager and Pioneer spacecraft outside our solar system. We're planning to send probes to nearby star systems. There's no reason extraterrestrials couldn't send spacecraft into our solar system. And so we call that solar system SETI. And so the idea that there could be extraterrestrial artifacts flying around the solar system, whether they're broken or not, that's something I've been interested in for a while, and I think that's something we should continue to study. So the connection I think that a lot of people may have in mind is that if you have a free-floating craft in the solar system that's of alien origin and it enters Earth's atmosphere, now it's a UAP. And I'm not sure, I haven't seen any evidence myself to connect the two, to connect the UAP that have been observed over time with this idea of solar system SETI. But I acknowledge the fact that hypothetically, if there were a spacecraft, alien spacecraft flying through the space, it would be of interest to SETI up until the moment it enters the atmosphere. And now it's called a UAP. And because of the stigma, we can't study it. And so that particular scenario, I'm not convinced that that's what we have seen yet. But you have to keep an open mind in that sense that you can't, because it's stigmatized, it just creates this problem where, in that one hypothetical, SETI would miss the thing it's trying to find. Mm-hmm. So in that sense, if we found that they were extraterrestrial, no, I would be excited then, because it would tell me that there is a connection between solar system SETI and UAP. Mm-hmm. I don't see the connection now, but I would be excited to find that there was a connection.
Mm-hmm. So they're not mutually exclusive. Pilots have a great view, of course. But one of the audience members writes in, what about the astronauts on the International Space Station? Has anyone contacted them and wondered what their eyes in the sky might tell us?
Not that I'm aware of.
No, okay. All right. Well, the final question then, you gave us the big picture question of what you would like this to be and what you personally would get excited about. Nice to know that Ravi would get excited about alien craft. What can the public do? And is there anything that someone writes, anything that the regular folks can do to contribute to the efforts around UAP research?
Well, there's bills in the Senate right now, and I think Congress is generally interested in this. So I think that's something you can do, is just write to your Congress people, tell them that you're interested in this. I would say try to decouple it from the pseudoscience and from the just focus on what we've been talking about here, that there's a need for further scientific investigation. And I think the more Congress hears from people that they care about this, and that it's in a coherent, rational, scientific argument, I think that'll only help.
Lovely. Well, Jacob and Ravi, thank you so much for joining us tonight. It went by so fast for this SETI talk, discussing whether or not UAPs should be investigated scientifically. I think you made a very good case that they should be. I'll turn things over to Bill now.
In any case, I do want to again thank you, Molly and Jacob, and Ravi, and also I want to thank you in our audience for your great questions. And of course, like always, we never really have time to address them all, but I hope we addressed some of the ones that you thought were particularly interesting. I do want to point out again that, as always, we reached a really global audience this evening, and I think that just proves again that curiosity truly does unite us all as human beings, regardless of our language, our gender, our race, or our ethnicity. We share this common curiosity. In the United States, we had people from, and internationally, we had folks and friends with us from Mexico, Canada, Peru, Colombia, Italy, India, Australia, Ecuador, Norway, the UK, Panama, and Argentina. So how wonderful to have such a global audience with us tonight. And thank you all for joining us.